Chapter 3 today. This chapter is on the history of the atom, and a lot of it is review for you guys before because you had it in middle school. So it includes this little section here in your vocab on atom, electron, proton, nucleus, and neutron, which you are familiar with. Then it's got a few in this area that's new to you, the atomic number, the mass number. We're going to talk about these. But then over here, it has this new section on nuclear chemistry. And I used to make this a very big unit, a huge unit actually. But because this material is not on your midterm, I cut this way down. So now it's a very small unit. So I will not be here next Friday. And so I am planning on testing next Thursday on this unit.
Right before the quarter.
Okay, so your unit vocab quiz will be on Tuesday, 1 week from yesterday. Tuesday, 10/11. All right, that is formally announced. I have not formally announced the test for next Thursday. I have not, because I want to make sure that we're going to actually make it. The problem is if we don't, I'm not going to be here Friday, and then you guys won't be here Monday, which means that postpones this another week to close. All right. So we're going to start. We're going to get through all these notes and then get you to study. And I will have to figure out how to assess it. It's my job as a teacher to figure out how to assess it. So that's in my hands, okay? All right, here we go. Okay, so Democritus was a philosopher 2,000 years ago. And he began to think, this is like before science, right? He began to think, I wonder what would happen if I started to divide matter and divide it in half and 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 just kept dividing it in half. Would it go on forever? And he said, no, I don't think it would. I think eventually matter would become indivisible, teeny tiny little particles. And they would be these hard, indivisible particles that you couldn't divide anymore. And he said, and because matter is all different, rocks are different from water, which is different from air, I think eventually these teeny tiny different particles would be different shapes and sizes. And then he said, I'm going to call these different particles atomus. So basically, Democritus, without science, he was the first one to say, oh, look, there's atoms, and they are all different, right? And he called them atomus because atomus means indivisible. So now we come 2,000 years forward into the 1800s. Now, at this time, there was both knowledge of elements as well as atoms, and the understanding that elements and compounds were different things. They had a basic, very basic understanding of the periodic table. Not a lot, but they did know that there were some elements that had properties that were the same, but not a lot. And a scientist named John Dalton, an actual scientist, he came up with the atomic theory. Now, the atomic theory had 7 parts to it. I've condensed it down to 4, and you need to know these 4. What John Dalton said is that all matter is made of elements, and that atoms of the same element are all the same. So all atoms of the same element are the same. He also said all atoms of different elements bless you, are different. So basically, what he said is all atoms of the same element are the same, and all atoms of different elements are different. But the thing is, we know that this is not true. Since John Dalton, we've come to know that all atoms of the same element are not the same. How do we know this? What do we know about atoms today that we didn't know about atoms now that lets us know that they're not all the same of the same element? Deep. Well, we know, what do we know about all carbon atoms that tells us that they're not all the same? No. The number of what? Nope, they have all the same number of energy levels. It's actually the number of neutrons, and they're called isotopes. All right? So today, we know this is not true. Due to isotopes. And one of the things that we're going to look at in this unit is the existence of isotopes, what they are, what it means, that kind of thing. All right? Isotopes is when an element, two atoms of one element have different numbers of neutrons, and neutrons have a mass of 1. So if a carbon has 6 neutrons, it will be lighter than a carbon that has 7 neutrons. Okay? Elements combine in fixed ratios to create compounds. We already know this. What is this called that we know this? The law of definite proportions, says Kelsey. Excellent. Good. All right, so that's the law of definite proportions, and we already know that. And the last portion of this is atoms. Number 4, atoms of elements cannot be broken down further. But we do know something about this. We know that today, this is also not true. Well, it was 200 years ago. We're giving him a little bit of slack. Okay, we know that this is not true because of 2 things. Well, many things. Not because of... So first of all, on the easy part, we know it's not true because of protons, neutrons, and electrons. So we know that there are parts of atoms. Dalton didn't know that. He didn't know that there were protons, neutrons, and electrons. But we know even more than that. We know about nuclear chemistry. So let's talk about nuclear chemistry just for a minute, because we're not really going to get into it a whole lot. So nuclear chemistry, and if we talk about nuclear power, nuclear chemistry is about splitting the nucleus of an atom. And when you do that, a tremendous amount of power, a tremendous amount of energy is released. How much is a tremendous amount? Well, if I were to split the nucleus of 15 grams of uranium, how much is 15 grams? About what?
15
About 15 Skittles worth of uranium. Thank you, Miss Paxton, for that tremendous lab that for the rest of our life, we will always know how much a gram is. About 15 Skittles worth of uranium. The same amount of energy will be released as 20 train car loads of coal. So that is a huge amount to a little amount, right? A very little amount of energy for a huge amount of energy. So one would think, why don't we do that all the time then, right? This tiny little amount of uranium could produce a huge amount of energy. Well, the problem is when we split those nuclei, what we do is we create a tremendous amount of energy, which is changed into heat. That heat heats water, which creates steam, just like the steam engine, right? Because there's so much heat, it creates a tremendous amount of steam, which is used to turn turbines, gigantic turbines, which is then converted into electrical energy. That's how a nuclear power plant works. Yes, and so they have these rods that get up to this tremendous high temperature and everything. So that's fine. The problem is if there is an accident, it is an extraordinarily dangerous accident, which in our population puts tens of thousands and sometimes hundreds of thousands and sometimes millions of people at risk. And it's not just for immediate cancer, as in like in the next few years, it's also possibly for generations to come, because gamma radiation, nuclear radiation affects your DNA. So it could be that maybe you won't get cancer. Maybe just your children will be deformed, or you'll never be able to have children. Right. So this is not a small issue. This is a generational issue which could affect people for generations. And that's why people don't want nuclear power, because it is currently, as we use it today, it is not safe if an accident occurs. Now, do accidents occur? Yes. Often? No. But if, unlike plane crashes, which do not have accidents often, which, by the way, flying is still the safest form of travel, because plane accidents happen so rarely and so few people die in plane crashes. Yes, it's very, very rare that things happen. But and trains also. But the thing is, with nuclear energy, if something goes wrong, it will affect thousands and thousands of people. So it's not safe. Okay, so let's move on. Ben Franklin is the next scientist. So he's the one that you know of who flew the kite, right? Supposedly, he did not fly a kite. However, he did discover something very important about electrical power and electricity. He discovered that in electricity, there are both positive and negative charges in an electrical current. And this is super important, because when Ben Franklin worked with electrical current, he took it from not just being one electrical current, but from being able to be broken down into positive and negative charges, which, by the way, protons are positive and electrons are negative. And so now we can really begin to do some work on both atoms and electrical charges, and now light bulbs can be made, all kinds of things can be done. Because once we break down in positive and negative charges, now we can begin to have cathodes and anodes, and we can begin to now we can really begin to work with electricity as a functional and useful tool. All right, so we're going to stop here. You have homework for tonight that is due tomorrow. I do know that I have your Skittles labs. I apologize. I hate grading labs. I'm doing the best I can with them. They always go to the bottom of the list, labs do.